In this video, we are going to talk about BEV architecture, various components of a BEV, and the subsystems. So the major component of a battery electric vehicle includes battery, which is a high voltage battery, typically a lithium ion battery. This is connected to an inverter, which converts DC to AC. Typically, it's a three-phase DC to AC converter. Most commonly used motors is a three-phase motor. So the output of inverter is a three-phase AC current, and that connects to the traction motor. This constitutes primarily the high voltage system. Battery not only powers the vehicle but also powers the auxiliary circuit. So we also have a low voltage system which powers all your auxiliary consumptions, including mobile chargers, infotainment system, headlights, and so on. So the offload is powered by a smaller 12 or 24-volt lead acid battery. Lead acid batteries are typically cheap and hence are used for low voltage system. The lead acid battery is in turn charged by the high voltage lithium ion battery whenever needed. Since there is a difference in the voltage, these two systems are interconnected via a DC-DC converter, which has its own inefficiency but helps in stepping down the voltage. So as we move from high voltage to low voltage system, as the name suggests, the voltage across the terminals drops. Now the motor is connected to the driveline. So in some cases, we might have a transmission, but in typical passenger vehicle, electric vehicles, the motor is directly connected via K reduction. It's also known as E-axle. So the motor and transmission are coupled. It's a single speed transmission. In some cases, it may also be a dual speed transmission. So the motor would then be connected to differential, which helps in transferring the load or the torque to the front and rear, to the left and right axles. So the differential is then connected to the right and left axles respectively, and the axles are then connected to tires. Similarly, we'll have arrangement of axle and tire on the other side as well. So we'll have a tire axle combination which would be freely rotating or connected to the motor depending upon whether it's a front wheel drive, rear wheel drive, or all wheel drive. All wheel drive vehicles have an advantage of higher gradability because of more traction. We'll talk about traction control in a later video, more detail. The vehicle chassis is connected to all the four axles. And this is a typical architecture of a four-wheeler battery electric vehicle. In this case, we also have some losses in the form of aerodynamic drag, which comes from the shape of the vehicle. There is rolling resistance force, which comes due to the interaction of tire and road. There will be mechanical efficiencies of all the components like shafts, differential, axles. There will be inertial losses. When we accelerate the vehicle, all the inertias or shafts or mechanical components would rotate and accelerate based on the vehicle speed, and that requires some torque. So we'll talk about power flow and energy flow in the next video. But this video hopefully help you understand what are major component subsystems of a typical battery electric vehicle.